Welcome back for another deep dive. Today, we're going deep on something I know you're really interested in, machining.
Yeah.
But, we're not going to just, sit here and read some boring textbook, are we? We're going to go on a wild ride from the very first stone tools all the way to those crazy smart factories they're building today.
That's right. We're talking about a journey that literally spans millions of years, and you'll see how this process, which seems so basic, has shaped us, as humans, how we evolved
Right.
and how it's still changing the world all around us.
I know, it's crazy. So we're using this pretty in-depth technical source all about machining.
Okay.
And guess what? The first thing it talks about is the Stone Age.
Really?
It says that people, way back then, 3 million years ago,
Wow.
were already using stone tools. I mean, that just blows my mind.
3 million years. That's just incredible. I mean, think about it. That very first time someone picked up a rock, right, and figured out how to make it into a tool, that changed everything for us as a species.
Totally. And the source really emphasizes how, having those tools meant people could eat better, especially getting more meat and fat in their diets.
Mm-hmm.
And it wasn't just about, getting full. It actually, supercharged our brains.
Exactly. A better diet gave our brains what they needed to grow, to become more complex. And you know what happened then, right?
Well,
Those bigger, more complex brains, they led to even better tools. It's this amazing feedback loop, we upgraded our mental hardware, and that paved the way for basically everything that came after.
It's amazing, isn't it, to think that something as simple as a sharpened stone could be connected to how intelligent we are today. But okay, here's something that really jumped out at me from the text. It talks about this huge gap between those early tools and what we think of as the first industrial revolution, which is, around 1760.
Right.
So we're talking millions of years compared to just a few centuries. What took so long?
Yeah, that's the question, isn't it? It's like this chicken and egg problem. What machine did they even use to make the very first machine tool?
Right.
It probably involved a lot of things happening slowly over time. People got better at working with metal. They figured out how to use water and wind for power, maybe even some lucky accidents along the way. Who knows?
Then, bam! Just 50 years later, we get Industry 2.0.
Wow.
The book calls it Fordism, because of Henry Ford and how he changed mass production.
Yeah.
But then it makes this weird connection to McDonaldization. Now, I don't get that. What do burgers have to do with car factories?
Well, it's all about systems and standards, right? Both Ford with his assembly line and much later McDonald's, they figured out how to break down these big, complex processes into smaller, simpler steps that anyone can repeat. And they could do it super efficiently.
Okay.
This made production predictable. It could grow really big whether you were making a Model T or a Big Mac.
Oh, now I see. It's like a recipe for being super efficient, and it works for both cars and e-burgers. Exactly.
So we have early humans making huge leaps forward thanks to tools, then this slow climb for ages, and suddenly, bam, mass production changes everything. What's next?
Computers.
Yeah, you got it. Industry 3.0 is all about computers, and how those early computers developed is what led directly to the CNC machine.
CNC.
It stands for Computer Numerical Control, and that is where things start to get really interesting.
The text gets into some of the details about how this all came about, and it's surprisingly interesting. There's this part about the invention of ladder logic programming.
Oh, right.
Really caught my eye. Can you explain what that even is?
Absolutely. So ladder logic was a total game changer. It's what let engineers on the factory floor, people actually working with the machines, actually use these CNC machines.
Okay.
Before that, it was mostly computer scientists, stuck away in their labs who could even understand them. Imagine a programming language that, anyone could look at and understand, even if they weren't a computer whiz. It was based on how engineers were already designing electrical circuits.
Oh.
This made CNC technology something that a lot more people could use and understand, which is why it became so popular so quickly.
It's amazing, isn't it?
Yeah.
The text even mentions some of the people who were behind these innovations. There's Automati, the company that made the first programmable logic controllers. And then there's George Boole, this mathematician whose work, way back when, actually led to digital computing as we know it.
Wow.
It's just incredible to see how these things that seem totally separate actually came together to change how we make things. Are there, other important people or companies mentioned in the text?
Oh, yeah, definitely. There are a bunch of fascinating people and companies that pop up throughout the book. We'll get to more of them as we go deeper into the more modern era of machining. But before we get to the really cutting edge stuff, let's make sure we're all on the same page about how these CNC machines actually work. The text does a great job of explaining the basics, and it's surprisingly easy to understand. Can you walk us through it?
Sure, let's do it. I'm ready to get under the hood of these amazing machines.
All right. So the main idea with the CNC machine is that it's all about really, really precise movement.
Okay.
It's almost like watching a dance, but it's a dance of motors, gears, and cutting tools, and the choreographer is the computer program.
Wow, that's a great image. So how do they get that level of precision?
Well, it all starts with the basic parts. Think of it like a really powerful, high-tech sculpting tool. You have the bed, which is the solid base, just like the foundation of a sculpture. And then you have the spindle, which is what holds and spins the cutting tool, kind of like how a sculptor would hold a chisel.
Okay, so the bed and the spindle are like the stage in the artist's hand.
Right.
Got it.
Mm.
But what about the actual movement? How does the tool know how to carve out the right shape?
That's where the drives come in. These are the motors and mechanisms that move either the cutting tool itself or the material being cut. And they move with incredible accuracy in specific directions. Imagine that sculptor guiding their chisel, really precisely, following a path they planned out beforehand. And then you have the controller, which is like the brains of the whole thing. It's
Right.
like the conductor of an orchestra, making sure all the parts work together to create this, masterpiece. And remember that ladder logic programming we talked about earlier?
Yeah.
That's what tells the controller exactly what to do.
It's incredible how all these pieces fit together. The source even zooms in on this one specific part called ball screws, saying they're amazingly precise. What makes them so special?
Ball screws. Oh, man. They are a great example of how clever engineers can be. They take the spinning motion, like from a motor, and turn it into the straight line movement, which is how the cutting tool moves. And they do this with incredible accuracy, thanks to these tiny little ball bearings that, recirculate as the screw turns. Think of it like a super smooth, super precise screw that lets the machine make those really tiny, delicate movements that CNC machines are known for.
It's amazing how these tiny parts can have such a big impact on how precise these machines can be. The source mentions all these different types of CNC machines like lathes, mills, grinders. What are the differences?
You can think of each type of CNC machine as like a specialist with its own, skills and talents. Lathes, they are the masters of making round things.
Okay.
Stuff like shafts, rods, anything with that round profile. The way it works is the workpiece spins while the cutting tool stays still and shapes it.
So kind of like a potter shaping clay on a wheel.
Exactly. That's a great analogy. Then you have mills, which are all about shaping these complex surfaces.
Yeah.
Unlike a lathe where the workpiece spins, in a mill, the cutting tool is the one that spins and it moves across the material. It's like a high-tech carving tool that can make all these intricate 3D shapes, slots, grooves, pockets, you name it. If you need something with, really precise angles, curves, details, a mill is the way to go.
Got it. And then there are grinders, right? What are those for?
Grinders are all about precision and smoothness. They use these abrasive wheels to take off tiny bits of material,
Mm-hmm.
leaving behind these super smooth surfaces, really precise. That's super important for a lot of applications.
So it's like the final polish, making sure that the finished part is absolutely perfect.
Exactly.
So lathes for round stuff, mills for complex shapes, and grinders for the final touch. It's like they're a team, each with their own unique skills.
That's a great way to put it.
It's incredible how far we've come from those simple stone tools, isn't it?
It really is. And speaking of advancements, let's talk about the future of machining. The source lays out 6 stages of how companies are becoming more modern, from those, traditional workshops to those mind-blowing smart factories we hear so much about these days.
Ah, yes, Industry 4.0 and beyond. It's a really hot topic, but I have to admit it can feel a bit overwhelming sometimes. Can you break down those 6 stages for us?
Sure. The text presents it as this step-by-step process where each stage builds on the one before it.
Okay.
It starts with stage 1, which is basically the starting point. Companies at this stage are still doing things mostly by hand. They have
Right.
very little automation and use very basic computer systems. It's kind of like the foundation that everything else is built on.
So stage one is like that traditional machine shop
Oops.
where skilled craftspeople are doing most of the work.
Exactly. And then we move on to stage two, where companies start to experiment with digital manufacturing.
Okay.
They start using standalone CNC machines and using computer-aided design or CAD tools. This stage is where they start to use computers and automation in the design and manufacturing process.
So it's like taking those first steps towards a more digital workflow. What's the next step?
Stage three is where things get really exciting.
Uh-huh.
This is where companies embrace virtual simulations and cloud-based services. They start to create digital twins of their products and production lines, basically testing and refining their designs in a virtual world before they actually build anything.
That sounds super efficient. It's
Yeah.
like having a virtual testing ground where you can experiment with your designs without having to spend a ton of money and time on physical prototypes.
Exactly. And it doesn't stop there. Stage four is all about connecting all those different systems and data sources, creating this integrated ecosystem for manufacturing.
Okay.
Think of it as breaking down those walls between departments, so design, engineering, production, even customer service. They can all share information and work together seamlessly.
So it's like the factory becomes a single living organism with all its parts connected and working in harmony.
That's a great way to put it. Then comes stage five, which focuses on using all that data to predict what's going to happen in the future and to optimize processes.
Right.
Companies at this stage are moving beyond just reacting to problems.
Mm-hmm.
Instead, they're using sensors, data analytics, and machine learning to predict when a machine might break down and take action before it actually happens.
That's amazing. It's like having a crystal ball that can tell you when something's going to go wrong,
Yeah,
allowing you to fix it before it becomes a big problem.
exactly. It's all about anticipating problems and preventing them, making things more efficient and reducing downtime.
So we've gone from manual processes to interconnected systems and predictive maintenance. What's the final stage of this whole modernization journey?
Stage six is the culmination of all these advancements. This is where artificial intelligence, or AI, comes in.
AI.
Companies at this stage are using AI to optimize everything, from production schedules and resource allocation to quality control and even adaptive manufacturing.
AI taking the reins. That sounds really exciting, but also a little scary. What does that look like in the real world?
Imagine machines that can actually learn from their own performance, adjust their processes based on real-time data, and even predict changes in demand or supply chains. It's a world where factories are no longer static things, but dynamic, adaptable organisms that can evolve and optimize themselves without needing a human to constantly manage them.
It's like the factory becomes self-aware, constantly learning and improving on its own.
Exactly.
So we've got this roadmap from those traditional workshops to these AI-powered smart factories. But the source doesn't just stop at describing these stages. It actually dives into some really cool stuff happening right now with Industry 4.0.
You're absolutely right. It's not just theory, it's happening now. And the source highlights some really cool, really transformative examples.
Like what?
For instance, it talks about the Internet of Things, or IoT, being used for things like machine monitoring and predictive maintenance.
IoT. I've heard that term a lot, but I'm still not entirely sure what it is. Can you break it down for us?
Think of it as connecting everyday objects to the Internet, allowing them to send and receive data. In machining, this means putting sensors in machines and tools so they can tell us their status, how they're performing, even potential problems, all in real time. Remember those ball screws we were talking about?
Yeah.
Imagine having sensors in them that track things like temperature, vibration, other signs of wear and tear.
So instead of waiting for the ball screw to break, which could shut down the whole production line, you can monitor it remotely and know ahead of time when it needs to be replaced.
Exactly. It's shifting from reactive to proactive maintenance, preventing expensive downtime, and keeping things running smoothly.
That's really powerful. It's like giving these machines a voice so they can tell us how they're doing and what they need. Are there any other cool examples of IoT in action?
The source mentions a really interesting example of using IoT to prevent tool theft, which is a huge problem in some industries.
Tool theft. I never really thought about that as being a big issue.
You may be surprised. We're not talking about someone swiping a screwdriver from a toolbox. We're talking about these expensive, specialized cutting tools used in CNC machines. Things like carbide inserts, end mills, drills.
Oh, okay.
These tools can be really valuable, and in some parts of the world, they've become a hot item on the black market.
Wow, I had no idea.
Yeah.
So how does IoT help with that?
Imagine putting tiny RFID chips in each tool. These chips can be tracked using sensors, letting companies know where their tools are at all times. They
Hmm.
can set up virtual boundaries, and if a tool goes outside of that area, an alert is triggered.
That's incredible. It's like having a GPS tracker on every single tool. Are there any other cool ways they're using IoT for this?
Oh, absolutely. Some companies are now using smart drawers to store their tools.
Smart drawers.
These drawers can only be unlocked by authorized personnel, like using fingerprint scanning or digital keys.
That's like a high-tech toolbox with its own security system.
Mm,
That's really smart.
right. And it's not just about preventing theft. These smart drawers can track tool usage, which helps companies manage their inventory better, spot potential training needs, and even prevent accidents by making sure the right tools are being used for the job.
It's amazing how something as simple as connecting tools to the internet can have such a big impact, improving security, efficiency, and even safety. What other cool stuff about Industry 4.0 is this source talking about?
Well, we can't talk about modern machining without talking about robots.
Robots. I knew we'd get to them eventually.
Of course, they're a key part of this whole Industry 4.0 revolution. But here's what's really interesting. The source goes beyond just describing the tech itself. It also looks at what this robot revolution really means, the bigger picture.
I think that's really important. There's a lot of talk these days about robots taking over jobs. Does the source address that?
It does, and it takes a balanced view. It recognizes that robots are getting better and better at doing things that are repetitive or physically demanding, but it argues that this actually frees up human workers to focus on things that are more complex and creative.
So it's not really about robots replacing humans, but more about robots and humans working together in new ways.
Exactly. It's about collaboration, not competition. Robots can handle the heavy lifting, the boring, repetitive tasks, even work in dangerous environments.
Hmm.
This allows human workers to focus on things like solving problems, coming up with new ideas, things that require critical thinking, creativity, and adaptability.
That's a much more optimistic way to look at it. It's not about humans versus robots. It's about humans and D robots working together to get things done better, faster, and maybe even more creatively. Does the text give any real-world examples of how this human-robot teamwork is actually happening in machining today?
Absolutely. There's a fascinating part where it describes how robots are being used to load and unload parts from CNC machines, do quality inspections with amazing accuracy, and even assemble really intricate components. It also mentions the use of cobots, which are these collaborative robots specifically designed to work safely alongside humans.
Cobots.
Hmm.
That sounds like something out of science fiction. What do they do?
Think of cobots as robotic assistants working right next to human operators to help them do their jobs better.
Okay.
They can help with tasks that require precision and dexterity, basically acting as an extra set of hands guided by a human expert.
It's amazing to think how this kind of teamwork is changing how things are made. The source also mentions a bunch of robotics companies and open source software projects that are driving these changes.
Yes, and this part might be particularly interesting for you. It lists companies like ABB, Phonic, QK, Universal Robots. These are the big players in the robotics world.
So potential job opportunities or maybe inspiration for some DIY robotics projects.
Exactly. The text also mentions open source software projects like ROS, which is the robot operating system, and Move It, which is a motion planning framework.
I see.
The world of robotics is becoming more and more accessible because of these open source tools and communities. They allow people to experiment, learn, and even contribute to developing new robotic applications.
It's amazing to think about all the possibilities. We've talked about this incredible journey from those first stone tools to these high-tech smart factories, but I can't help but wonder, what's next? What comes after Industry 4.0?
Right. It's like, where do we go from here?
Exactly. The text kind of hints at what Industry 5.0 might look like. It mentions these like self-learning factories where machines can actually optimize themselves without any human intervention.
Yeah, it's a mind-blowing concept. Imagine a factory that's constantly adapting and getting better, responding to changes in demand, even predicting problems before they even happen.
It sounds like something straight out of a sci-fi movie.
Mm-hmm.
But if machines become that independent, what happens to the human workers? Do we all just get replaced by robots?
That's a question a lot of people have, and the source acknowledges that. But it's not about getting rid of humans altogether. It's more about changing the roles we play. As machines take over those routine jobs, human workers can focus on things that require higher level thinking, problem solving, and creativity.
So it's not robots versus humans, it's more like robots and humans working together in new and different ways.
Exactly. Think about it. If a machine can handle those repetitive, precise tasks, that frees up humans to do the things that machines can't do, like using intuition, critical thinking, coming up with those innovative solutions that really push things forward.
That makes a lot of sense. It's about each side playing to its strengths. But I'm still curious about what kinds of jobs will exist in this Industry 5.0 world. The source gives a few examples, right?
Yes, it mentions things like robot trainers, people who teach robots how to do new things or adapt to changes. It also talks about human-machine interface designers, people
Yeah.
who create those user-friendly ways for humans to interact with these super complex automated systems.
So it's not just about engineering skills, it's also about understanding how humans and machines can work together effectively. Sounds like a lot of opportunity for people who can bridge that gap.
Absolutely. And we can't forget about the ethical side of all this. As machines become more independent, we need to make sure they're operating safely, fairly, and responsibly.
That's a good point.
That's going to require new ways of thinking about oversight, accountability, and the values we build into these systems.
It's a good reminder that technology is just a tool. And like any tool, it can be used for good or bad. It all depends on the choices we make as a society about how we develop and use these powerful technologies.
Couldn't agree more. As we head towards Industry 5.0, we need to think not only about the how, but also about the why. What kind of future do we want to create, and how can we use these advancements to benefit everyone, not just a select few?
Big questions to ponder. It's clear that machining has been incredibly important in shaping our world, from those very first stone tools to these self-learning factories of the future. It's an amazing journey that's far from over.
It really is. And what's so exciting is that we're not just watching this happen, we have a say in how it unfolds. We can shape the future of machining, steer it in a direction that benefits both humanity and the planet.
That's a really empowering thought. It's not just about what machines can do, it's about what WE can do with machines. Any final thoughts for our listeners before we wrap up this deep dive?
Stay curious, never stop learning, and don't underestimate the power of human ingenuity. We've come a long way from those first stone tools, and who knows what incredible innovations await us in the future.
Well said. I know I'm going to be looking at the world around me in a new way, thinking about how machining is behind everything, from my smartphone to the car I drive.
It's everywhere, shaping our lives in ways we often don't even realize.
Well, thanks for taking us on this incredible journey through the world of machining. It's been truly eye-opening, and I'm sure our listeners feel the same way.
It's been a pleasure.
Until next time, keep exploring, keep learning, and keep asking those what-if questions.